name is Matthew Shupe, and I am a research scientist at the University of Colorado and NOAA in Boulder, Colorado. And I was also the co-coordinator for the MOSAiC expedition. MOSAiC is the Multidisciplinary Drifting Observatory for the study of Arctic climate. And we basically took an ice-breaking ship and froze it into the Arctic sea ice for a full year to serve as a platform for looking at the whole coupled Arctic system. So that's the atmosphere, the sea ice, and the ocean all interacting together. It's a really important area to study right now because the Arctic is changing so rapidly, and that's why we went to the Arctic, to go look at the sea ice and to probe the sea ice and understand why is it melting so fast and what effect does that rapid ice melt have on the rest of the Earth system, on the climate system, on the ecosystem, and other processes that are playing out across the globe. So there were a lot of different parts of the expedition, many different nations involved and many different institutions bringing all kinds of different observational activities, looking at the atmosphere, ice, and ocean, at the chemistry, at the biology, at the physics of this system. One of the important contributions was the Department of Energy Atmospheric Radiation Measurement Program's facility. This is a mobile facility that has all kinds of nice instrumentation for looking at clouds and precipitation and aerosol particles in the atmosphere, radiative energy transfer at the surface, and so many other processes. And using that kind of data, we can really start to characterize things like, and this is my area of research, things like the clouds and their radiative effect on the surface and how that ultimately leads to shifts in the energy balance at the surface, which then are important for things like how the ice melts, how it freezes, and other changes in the system that would be really important if you're interested in the trajectory of the Arctic system. So that's one area of research that I've been personally working on with MOSAiC, but there are many others going on that other people are looking at, including things like the annual variability of aerosol particles in the atmosphere. So we might get some insight into the sources of those particles and how they affect the clouds and the cloud processes. There are people looking at precipitation, snow falling out of the atmosphere and landing on the sea ice. That snow serves as kind of this insulator, this blanket for the sea ice, but it also reflects the sunlight in the summertime when the sun comes out. And so it plays kind of two different roles, and it's really important for the sea ice. And of course, characterizing precipitation is quite difficult as the different techniques we have can be affected by blowing snow and other things. So precipitation is another important area. There are so many others that we're really interested in. The winds. So the winds in the lower atmosphere, they blow on the sea ice, they push the sea ice, and it leads to a lot of breaking in the sea ice. And so this interaction between the atmosphere and the ice itself and how the ice moves and breaks is a really important one for us to understand and observe. And then, of course, all of these things that we're out there at MOSAiC to look at, to study, to understand, we then need to evaluate how our models represent those processes. So ultimately, we can identify the deficiencies in our models and hopefully improve on those so that our models can then represent the Arctic system in a realistic way, and in a way that we can then use those models to tell us what's going to happen into the future. How does the Arctic system continue to change, and how does that affect the rest of the globe? Or, can we forecast and predict sea ice into the future and how it might affect a variety of activities in the Arctic system? So that's MOSAiC in a nutshell. It was a really tremendous expedition, a great experience in the field with all the different international countries coming together. And in the end, I think also a very successful mission scientifically. We learned a lot, and we'll continue to learn a lot as we dig further into this data. Thanks for listening.